So these are problems. I'm not going to do, not going to create a similar problem for every problem on the quiz. I'm just going to um, overall be covering concepts that are on the quiz. Um, and it's obviously not in the same order. There are 10 problems on your quiz. I won't be doing 10 problems here. I'll just be doing, well, we'll see. I don't know how many I'm going to do. But right now, probably be four. I think four is good. Okay. So on your quiz, they might ask you something like this. They might give you a picture, and I have this kind of pared down. But on your quiz, it might say how far apart are two things from one another, and it'll draw a height, and it'll give you two angles of depression, and it'll say, find how far. Yes. Fine. So here, I'm asking us to find the distance, um, let's say, between the two people. How would I go about doing that? Well, um, there's an easier way than, because I don't actually need the hypotenuse. Okay. Um, yes, that is more work than you need because you can just, oh, I guess I should have told you. I'm so sorry. These are parallel. So you were right. You were right in your thought process there. But because those two lines are parallel, if this top angle here is 20, that means that this angle is 20. And if that top angle there is 70, it means that this angle down here is 70 because of alternate interior angle. On your quiz, it'll tell you that these are angles of depression. So then you would just know, okay, that's the ground down there. They're alternate interior angles. Now what? Yes. Okay, so let's see here. Let's work on this left-hand triangle first. So this is our hypotenuse. It doesn't have a value on it. This is our opposite, and this is our adjacent. And if we're trying to find the distance between the two people, this is what I'm trying to find. Now, what do you notice? Am I just going to be setting up one trig function here? Is that x the entire bottom length of that between the two people? You'll also have to find the right hand triangle as well, that bottom length. And then once you find the two, you'll have to add them together. But let's first find x. So we have 20 is our angle, that's our theta, right? So we're dealing with a here and o. Which function has a and o? So tan of 20 is equal to TOA over A, that's 30 over X. What do I do here to solve for X? Yeah, you switch and divide, I used to call it. You switch X being tangent of 20, or you can think of it in actual math terms, you multiply both sides by X, and then you would have to divide by tangent of 20. But either way, you would end up with 30 over tangent of 20. And so we pull out our calculator and we do, make sure it's in degree mode, 30 divided by tan of 20. And we get 82.42. Now, now is this our final answer? No. Obviously not, right? Because I need to solve for that y. Now y is on this right-hand triangle with the angle of 70. So that y is also my adjacent side on that right-hand triangle. So here I again am dealing with A and O. So it's again tangent, but this time the angle is 70 and it's TOA, so that's O over A. And it's the exact same process where I am switching and I have 30 over tangent of 70. I really hope this works. I really hope I created a problem that works. Oh, thank God. 10.92. Well, see, the thing is, I am not given the hypotenuse. I'm not given the hypotenuse, so you would have, you could, but you would have, no, you couldn't, because you can't even solve for the hypotenuse yet, because we don't have enough information. So here you would have to use um, tangent. Are you, yeah, make sure your calculator is in degree mode. Degree mode. Mine? A is just adjacent. So, like, is that better? Okay, okay. Let me plug. So from here, what do I have to do? Am I done? You circle these and done? Okay, yeah. Well, I asked for this. Distance between the two people. So to know the distance between the two people, I need to add these two values together. So I have 82.42 plus 10.92. And what do I get? Remember that you need to pull them. Now, could someone do it for me? Because for some reason this application won't let me pull from above. Um, remember, don't actually type these in. Pull it from the previous problems. And what did you get? I don't know if is that what people got without with pulling from the calculator? It might be. It might be the. It looks like it'll probably be the same. Yeah. Okay. So this time you would look out, and the unit is feet, and you're done. How do you pull it from the previous answer without rewriting it over? You would have to, and if I have, can you see me? So here, like if I was trying to add the previous two, I would just do the up arrow key until it's highlighted and press enter and it pulls it down. And then you do plus and do the up till you get to the other answer that you want and press enter again and it'll pull it down. And then you press enter and it will add them together. Does that make sense? Okay. So let me pause. So I'm gonna draw my little bird. Oh, my bird is gonna look like my hawk, isn't it? We'll call we'll do a little bird and he looks north, so I'm gonna draw a north line and my big hawk, okay? And then we notice a little butterfly This said a butterfly that is 10 feet exactly east. No, no, west from the bird. There we go. So we know that this angle is now 90 degrees because the butterfly is exactly 10 feet east west of our little bird. Then it says that the bird, oh, and also the butterfly sees the hawk at a bearing of north 20.4 degrees east. Now, what this means is, and you'll learn once you go and watch the instructional video on bearings. But what this means is, this is a butterfly that is 10 feet exactly west from the bird also sees the hawk. So the butterfly also sees the hawk. I know that's confusing. I probably should have worded that better. So you'll learn that there's something called bearing angles. Now, what this means is that from a line that is perfectly north of the butterfly, sorry guys, I'm still on a call. Um, from a line that is exactly north of the butterfly, if I go 20.4 degrees towards the east direction, which is this way, that will be my angle. So from the north line, 20.4 degrees is my angle. And it wants to know how far is the bird from the hawk. How can I solve this problem? The bird and the hawk. Yes, because they're both perfectly north. Yes, that's not how I solve this. But yes, you're right. Yes, because we have, what was that? Oh, I thought I heard someone else say something. That's fine. Yes, so would use tan here. How I solve this, I'm glad that you pointed that out, Isaac pointed it out. I did 90 minus 20.4 for this angle. Um, but his way totally works. So now we're going to do tangent of 20.4 equals TOA over A. And what do I do to solve this? Just like the previous ones, right? We switch the x and the 20.4, multiply by x, right, and then divide by 20.4. And so you get 10 over tan. We are using tan quite a bit, huh? 10 divided by tangent 26.89 feet. Bearings are another way to describe, like giving an angle a direction. Ships use it, airplanes use it. You know, instead of saying, "Oh, you need to go 24 degrees," they're like, "Which way?" You know what I mean? So a bearing is like a direction using a compass. Yeah. Any other questions on this problem? There's one other problem I wanted to go over, just one. So I'm only going to do three here. What's up, God? Because you're looking, so they gave us this angle inside the triangle, right? The opposite side is the side across from your angle, and the adjacent side is the one right next to the angle. So that's how we labeled O and A there. Okay. So problem number 3. It's just gonna be a quick. This is probably the easiest one. Those are the only 2 word problems, I believe. Again, I don't have my key on me. I just did. I just went over the 2 hardest ones. I can only get easier. Okay. So it's one of these problems. Uh, hmm. Let me 9 and 6. And the problem will say, um, find the trig function. Find the secant trig function of theta. Okay, so yes, go ahead. No, yes, no, never. Good question. You do not use the right angle. I am, the problem gives it to you. The problem draws it. So this is what you're given right here, just like this. Okay. Um, crap. My now my now my other device is messing up. So here, what did you notice is the issue with this problem? Yes, exactly. You know, secant relates to cosine, right? And cosine is adjacent over hypotenuse. Well, we're not given the adjacent side. So guess what we have to do here? We have to find it. We have to use the Pythagorean theorem to find that side. So let's call this C here. So to find the length of AC, we're given a hypotenuse and a leg. So that means it's the square root of the hypotenuse squared minus the leg squared. So 9 squared minus 6 squared is 45. Shoot, I didn't want this to simplify and it does. Let's do instead, yes, erase that 9 and put a, okay. I'm trying to get as small as I can without giving you away anything. So here, 7 squared minus 6 squared is 13. Can that be simplified? No, that is a prime number. So then we know that we need to have the adjacent, for if we're doing secant, we need to have the adjacent and the hypotenuse. So secant of theta, we know is opposite from cosine, which cosine is A over H. So opposite of A over H is H over A. So that means we have 7 over the square root of 13. Can I read my answer like this? No. I have to rationalize it. You have to rationalize the denominator. So you multiply by 13 over square root of 13, and you end up with secant of theta is 7, 13, square root of 13 over 13. And that, it doesn't even want you to solve. It just wants you to set it up. That would be your answer. If it had wanted you to solve, it would have just said solve for theta. But it says find the secant trig function. That means it wants you to set up the secant trig function without actually solving. You don't. I mean, not right now anyway. Don't worry about it. All right. Are there any questions? I know today was a lot. And I know for you guys, it kind of went out of order because I said, okay, we're doing the review. And then I said, okay, go back and watch the notes. Um, but I hope that you're not overly confused. And I hope if you are, you ask me questions. No, you don't need to know special grades. Nope. Mm-mm. Not for the quiz. Not for the quiz. What's up? That's it. Yep. As long as you, and I maybe would recommend you go and watch bearings, the bearing notes, just so you have a better understanding. Um, I also may tell you to go watch uh, there's a problem on their example 4, I believe, on the trig page. I would go watch that word problem as well. It just goes over, it's really, you only need to know. Go ahead. That's all right.